This time on Captain Castle's Laboratory, we have two Thomas Kinkade winding through the mountains from Hawthorne Village. This one is Christmas Crossing. So, all I've done to these, besides unwrap them from their packaging, was take the battery covers off, so make it faster. They pretty much arrived intact. On this one, though, one of the little lampposts broke. And you can see how small these are. So these are 1-inch squares. So it's less than 8 inches long. It's really small. But anyway, I'm going to move this over there so I don't lose it. And then I'm going to move this one over here because that's that battery cover. And this one over here. Actually, you know what? I'm going to put this piece with the correct battery cover. So I only have 4 AAAs left after Halloween, so I'll have to get some more, but I have it in one. So I'm going to turn one light off, and I'm going to fire this up. You see the train works, and you can see that the houses light up. And you can see that the houses on this side are brighter than the houses on this side. And the tunnel, you can see the tunnel right there where the train's coming out. I know it's hard to see. Let me get a little light. There you go. See, train tunnel lights up. So it's pretty cool. But these houses are dimmer. So there's 4 or 5 houses that are dimmer. And I don't know if this tunnel is supposed to light up right here. Light's coming back. Power's going off. I'm going to pop out the batteries. This does have the ability for AC power as well. Right there. Takes an itty bitty little plug. I probably have one. I just haven't looked. And now we're going to pop the batteries in here. And turn this one on. See, the train works. But pretty much no light. They're really, really dim. Like the camera's picking them up better than my eyeballs. But cameras are more sensitive to light. So, yeah, we have a slight issue. Or a light issue. Well, lights are coming back. There we go. So I'm going to just run the 3 lights on the bench and not the lights in the room itself, except for the big one behind me. That's a dim light compared to the rest of it. So why don't we open up the one that the lights are barely working. I'll just leave the batteries in here. If they fall out, they fall out. So there's 6 screws on the bottom. Let's move that one out of the way. The 6 screws. There we go. Whew. This one's going to be interesting. Not a lot of room. And it uses fairy wire. And the fairy wire is hooked up to individual LEDs. So I'm not too concerned about the fairy wire. I don't know if you can really see it because it's so thin. It's got a shiny like little hair that's parallel to the red. That's fairy wire. Also known as transformer wire. So like I said, I'm not too concerned about that. I have a roll there and a roll over there, and yeah, so we're gonna have more of it around here. But trying to see if there's an easier way to show you the internals without breaking anything, because they didn't really give you much slack. There is a diode on the power box, and I believe that is because of the AC power port on the side. It is, so it doesn't backfeed the batteries and blow the batteries up. Which it probably did anyways, because we do have corrosion in the battery pack. So there we go. Now you can see the wire better. So there's the motor. You can see right there. It is an identical motor to most Lemax. It's probably just an SRF series motor. You can see the little gearbox and the train track. And you can see every single LED all protruding out. I'm going to try and hold this so I don't break this wire. But they're all right there. So most likely they're just bad LEDs. Most likely. But all of them to fail at once is pretty unique. So I'll turn it back on, like so. See the track working. I'm going to go ahead and make sure my fingers don't interrupt the train. I'm going to turn the lights back off. I have to walk off camera so I don't drop the little box. There's all the lights, kind of like stars. Look at that. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 LEDs running off of these 4 AA or AAA. Sorry. Lights are coming back. It's gonna be one of those where I'm gonna turn it off and on probably a few times. So I'm going with one of a couple of things. Either there's some corrosion causing a reduced voltage. All the LEDs have failed, which would be unique. Or the diode is bad. Because the diode has a voltage drop, and if the diode is bad, there's a chance that the voltage drop is too excessive. Also, this one's clicking. I'm not sure why it's clicking. I don't see a cracked gear. I think the wire was touching, this black wire was touching the pulley. Because it was probably glued right here where there's a glue mark and grease. Yeah. And I bet you opening it up, it probably became free. So here's the meter. Let me put it somewhere where I can see it too. And I have to put a little more light on the subject. There we go. There's also a resistor hiding in here, so we got a diode and a big old resistor, and it's a big resistor. It's at least a 1 watt, maybe a 2 watt resistor. It's definitely gotten warm because it has changed the color of the glue. The glue is brown and black. I mean, that could be a failure point too. Maybe the resistor's overheated and the resistance has changed. Not sure, but let's figure this out. Resistor should just be for the lights. And it is. Okay. Reason being is this motor can run at 6 volts. Those lights can only run at about 2 to 2.5. So that's hot. And that's not. Right there. 3 volts. That's what's going to the LEDs with the resistor. 3 volts. This is interesting. The battery box is interesting. they have two branches of 3 volts. So it looks like there's 3 volts going to the motor and 3 volts going to LED. And that's why we have so many wires. There goes the train. And it's gone. I put my finger back. So the dark red wire. And we have a light red wire. Voltage shouldn't be dropping. So this has got a parasitic draw. Let's try this. Yeah, see how that's holding at 3.168? Oops, I moved my meter. Or my lead. Let's try that again. Oh, it's dropping too. Well, now I'm confused. Alright, I'm going to go ahead and try and pull this out of the glue so I can tip it up all the way. Well, I got a little bit out. Yeah, the lights are on. Okay. I just use a lot of glue in all the places I need to look. So I'm not cutting anything, I'm just using the snips to remove the glue, which apparently removed it from the battery box. Looks like there's corrosion. This might be part of the problem. There is, oh yeah. So I think that was supposed to be soldered to the battery box. You can't see because of the angle. I'm going to zoom in. So I was trying to remove the glue, and I'll show you what I'm talking about. Since I looked up and saw what I'm doing, you can't see because, focus, there we go. Alright, so I was trying to remove this glue from right here so I could get a better look. But instead of removing the glue, I removed the entire pad and it's really corroded. White corrosion. The battery acid, this is where all this white stuff is right here, that moves, has eaten through the solder joint. So it has literally separated the solder from the solder pads. That's what these are on this end. There's 4 here, 2 here. These are only 1.5 volts, while here to here is 3, here to here is 3. We have 3 here and then 3 here. So it's like 2 separate circuits that are controlled by one switch over here, right there. So here's your off-on switch, and here's your black wire. So this is a negative switch. So the plus side isn't turned off, it's the negative side is turned off. And then here's your negative for the motor. and here's your negative for the lights. And then your positives. You see how we have a orangish or a lighter red and a darker red positive? 3 volts and 3 volts. So this battery box, I'm going to slide it back over, is segmented. 1, 2, 3 volts. 1, 2, 3 volts. Very unique, very efficient, because you can separate the powers but tie the grounds or negatives together. That way you can get a 6 volt battery pack to run as 2 3 volt battery packs in parallel, so they can run 2 different things, lights and motor. Diodes on the motor, lights have a big resistor, which I'm going to try and show you that next. So I'm going to slide it back over and try and find the correct angle right there. There's the big resistor, and try and flip this over. That is the diode. That black right there is the diode for the motor, and that's the big old resistor right here for the lights. So the lights can't run at 3 volts. The amber lights usually run at between 2.2 on average is the good range. 2.5, 2.4 is the max. It has a very short spectrum of power before you burn the LEDs out. And then the motor has a diode, probably so it doesn't turn backwards. And when you put in the power, I'm going to move it over again. The power port's right here. That's what all these wires are attached to. So the power has a negative, which goes to here, which is why it's a negative switch. Then it has multiple positives, 2 to be exact. And what it's doing is the power port also goes into the battery pack and branches off. And I think the diode is there to control the motor and prevent backfeeding, because it's not going to save the batteries. I thought it was for battery saving when this was a 6 volt battery. Slide it back up. When I thought this was a full 6 volt battery pack, when it's actually a 3 and a 3 in parallel. So I'm going to try and remove this glue and this glue and this glue, and hopefully they don't break the solder joints like this one. So technically right now the light should work dimly, but the motor should be off. So I'm going to move the bright light and see if that actually is true. And no, the motor still works. What about the lights? Oh, the lights are even dimmer. That's crazy. They're on. Make sure it's not the light. Yeah, it's not that light over there. So this is a very interesting piece. What if I put this back where it was? Does it change anything? Not at all. Alright, well, let me see if I can remove those are glue globs. I'm not trying to remove. Yeah, that one came off. That's the one that's burnt. That's why it's like dark brown and black. And let's try and remove this glue glob. The reason I want to remove the glue globs is so I can see the connections, look for more corrosion, and try and figure out exactly what's going on with this piece. Because then I got to do it again on that side. Now that side only has about half of them not functioning right. This one has all of them not functioning right. I bet you it's the same cause, but the way that one's set up, the split might be different on how they split the power from the battery. I'm going to do the worst one first. Plus the other one, once I'm done with it, I have to set up a jig to hold the broken lamppost. Since that thing is like the length of a line on a ruler, it is itty bitty. It's a very small set. There's more of the burnt glue or melted glue. I didn't realize I was off camera again. I should zoom back out. There we go. Alright, so that's the negative. It's tied in right there. I'm gonna check the voltages again. I'll tell you what it says since I'm not zoomed out. But so this is positive and this is a negative. So when I touch these, it should be 3, and I'm getting 3 volts. And if I touch here, I get nothing. I get negative 3 volts. If I touch here, I get nothing. If I go this way, I get nothing. So maybe this one isn't connected, which doesn't make sense. So going from this pin to this pin is 2.3 volts. We just round it up. There we go. Nothing across these, just out of curiosity. Nothing on this back one. I got 1 volt on the back one there. What about from here to here? 1.3, 1.3, because there's a draw on those AAAs. See if I can figure out the voltage drop on this resistor. The bottom of the resistor is glued too. Not showing a voltage across the resistor. There we go. 1.2, 1.23 volts. All right, let's figure out what the resistance is of the resistor. There we go. Set to resistance. Apparently I hit the button too many times and set it to capacitance. Alright, the resistor is coming up as boom, boom, boom. Hell if I know, because I just slipped. This bottom one's hard to get to. 593 ohms. At 1 watt. That's a pretty big resistor for these lights. Alright, so I'm going to zoom out. And it should focus. There we go. So there's the glue that was breaking off. So I'm getting good power to the lights. The lights are actually showing they're getting about 2.2 volts, which is what they should run at. Let me get this out of here. Let's check what's actually going to the light itself. Just thought about that. I'm going to turn this bright one off and move it out of the way. Also, this will tell me which wire's hot and which wire's not, since you can't tell because they have a big old bundle of glue right here, so you can't tell which way it branches. So the inner track is the negative, and I'm getting a 1.789 volt drop on that LED. You can see. I can't see, but you can see. I'll just look at the viewfinder. And let's try this one up here. think that was the same 1.7. Yep, so that's the same. Well, I don't think the LEDs are bad. I think the problem is there's corrosion on all the contacts because everything goes through the battery box, whether it be the batteries or the AC power right here. And I think the corrosion buildup from the exploded batteries is causing the problem. Since you got all this, the white dust from the battery, and you can see that contacts are bad. I'm going to grab a little yellow LED and I'm going to turn it on at 1.7 volts and see how bright it is compared to what's in here. Because I'm curious. I'm thinking this corrosion. I'm thinking this thing needs to be a good scrub down with some alcohol and a toothbrush. There we go. I'm going to close this so I don't break that little wire. Orange. Should be about the same color hue as what's in there. I mentioned this before, but in case you haven't ever seen one, the LED, the lead that's longer is positive, the lead that's shorter is negative. If you trim the LED and you're not sure, the lead that's negative has no ridge on the side. I'm not going to do that until I turn on my machine, because right now my machine's set to the point where the LED would burn out. So I have it set for 1.7 volts, and because you all can't see the machine, so 1.734 to be exact, or 1.737. It's very dim. Look at that. Kind of like what that's doing. But if I bump it up to 2, that's 2.15. Look how bright that is. Now, the way I sort out my LEDs is always leave the info in here on the voltage. And these are rated for 2 to 2.2 volts. So that's 2.15, of course. So if I bump it up to 2.2, the machine doesn't have the extra decimal point, so it says 2.2. So all I see is this on the machine. So that's full brightness, and that's pretty bright. And then if I drop it down to the minimum of approximately 2 volts, 2.1, doesn't look too bad. It's flickering because of the clamps. But at 1.7, come on. I wish this had a fine adjustment knob. My other machine does. Yeah, that's really dim. So I think the first thing I'm going to do is I'm going to take the battery contacts out and scrub them down with rubbing alcohol and see if we can get better conductivity through them. I'm thinking that is our big issue before I start removing all the LEDs, because it can be a pain in the butt because of those little thin wires. I have wire to replace it, but I'd prefer not to deal with wire wrapping them and soldering them, wire wrapping and soldering them. It's tedious work, and I don't think the LEDs are bad. I think our problem is the power coming out of the battery box. So I'm going to pause the camera while I do it, but this is what I use. Let me turn the light here. Isopropyl, 99.9% alcohol. I bought one of these from Walgreens a while ago. I just refill it because this one says 91%. So use this for cuts and scrapes and general purpose cleaning, and then once it ran empty, I refill it. I used to have the big 1 gallon jugs as you've seen in the past if you watch previous videos. Those are cumbersome. These are much easier to store, and they're the same price. You get 4 of these, which makes a gallon, or you can get 1 big gallon. These fit better in a cabinet than the big jug. So turn that off. And now if you don't have isopropyl alcohol, white vinegar works too. I just don't want my laboratory smelling like vinegar if I can avoid it. A toothbrush works. I like for a toothbrush medium or stiff bristle. Usually I use the vibrating one that I have, but I found this one in my drawer. It's got a stiffer bristle, so I'm thinking it might work better on this corrosion. You can also use the real brushes that you can buy in packs at your hardware store that have brass and metal and nylon bristles. Don't use the metal ones. You can get away with the brass in some context, but the nylon ones are the best. I don't usually use those because they usually have a fatter head, which makes it harder to get into the slots where the batteries sit. So this, you can see, is narrower than a AA, so it fits into the battery box because it does AAA, AA, so on and so forth. The other ones don't fit into the AAA or AA spots. But that's what I'm going to do. I'm going to take the batteries out. I'm going to clean the contacts on the top and the bottom. Once I clean my bench a little bit here so I have some room again. I don't need this jug yet because I already refilled the container. So I'm going to take the battery out. Batteries. The reason being is isopropyl is flammable. And even though it's only 1.5 volts per battery, and it's just a little battery, everybody's like, oh, it's just a little battery, it's okay. You know that your sparker for your barbecue grill can run on a AAA? You don't want to touch that. You know that a taser runs on batteries? You don't want to touch that. And I don't know about you, but alcohol fires, you don't feel them right away, and they burn relatively clear, and they hurt. So just to be safe. So what I want to show you before I pause the video and start cleaning, look at that corrosion. See that corrosion? This side's not near as bad. It's pretty shiny. There's a little bit on the edge, but it's mostly on this side where all the batteries leaked, which is so weird. It's on all 4 terminals instead of just 2 and 2. Because they usually only leak from one of either the anode or cathode end of the battery. But the side that it leaked on is where it started corroding all these solder joints, especially this one here on the end, where this solder joint on the diode is all jacked up. So we're going to clean them off. And once I clean them, I might retouch up the solder joints, like this one here. So you can see how that one's shiny and that one's dull. This one's got corrosion. So in case the corrosion has caused any pinholes or got into any cracks or crevices in the solder joint, I don't want the corrosion underneath that'll start to degrade the joint and cause it to separate or break. So once I clean them, I'm just going to hit it with a soldering iron and a little bit of solder, re-adhere it, and then we'll test it again and see if we get more than 1.7 volts out of it. All 4 of these batteries are brand new. I know one's not the same as the others, but that's because when you buy packs of them, yeah, sometimes you buy multiple packs and then your objects take 3 batteries or 1 battery and it comes in 4 packs. So you get all balls. And that's what I have there. But they're all brand new. They're all putting out about 1.5 volts with no load, which is what they're supposed to put out. I check my batteries before I start the video if I need batteries. I will also see if I have anything that will fit in this port and run a 6 volt DC input. Whether it's a pre-made one or if I have to hook it to my machine, I will see if I can find something so I can test it both on batteries and DC power from a direct solid source. That doesn't degrade like batteries do. And the longer you run batteries, they degrade and lose power. So, alrighty, enough talking, and let me get to work. You've seen me do this before. I'm going to clean the terminals, both inside and out, and then I'm going to touch up the solder joints, find a power port, and we'll be right back. Okay, we're back with the first of two Thomas Kinkade pieces here. And part of the problem is this is the diode that was right here. The diode's actually leaked. It's gotten hot. You can see the corrosion coming out the end. So I cut out the diode and replaced it. The diode is a, let's turn that around, a 1N5817, which you can't see because the white lights are swamping out the number. Do that. There you go. A 1N5817. That's what's written on the side of this one. That's what I soldered in. The diode kits, you can get them on Amazon. They look like this, and they tell you all the information right there. There we go. So, got my LEDs just in case, and it is brighter. It moves better with the diode. It moves better with direct power, and is slightly brighter with direct power as well, but that's pretty standard with things that run on batteries. And it could be the age, because newer stuff is better controlled. So let me stop talking and show you. So I'm going to turn the lights off. I have 4 brand new batteries in here. They literally were just delivered an hour ago in my orders. So just to be safe, I have 4 brand new batteries because I've been running this while cleaning all the corrosion so much that I'm reducing the power of the batteries. So here we go with 4 brand new AAAs. Lights are going off. There we go. Let me let the camera adjust and switch. Now I know it's hard to see because they're still relatively dim. I'll bring it up and you can see we have lights, and I get the bottom back off. It always gets caught on the switch, and you can see all the lights are right there. Now, what the diode does prevents you from backfeeding it if you plug in the power with the batteries in, so it doesn't blow the batteries up, because that would be bad. So I'm going to plug in that, and I'm going to turn on the juice, but just to show you, I'm going to pop the one of the batteries out. It's hard to do it in the dark. So even with the battery out, it still runs. Remember how I said it had that split circuitry? Very interesting the way they do this. You have to take 2 batteries out, one from each of the 3-volt legs. And now we're going to give it juice. And here's the lights. They're brighter. You can see they're actually quite a bit brighter. And the train moves. Oops. Let's turn it off. Lights are coming back. There's 1. There's 2. Oh, power's off. Early. So okay, we're back with the Thomas Kinkade Christmas piece here, or holiday piece. So I had to replace the diode. The other diode was bad. That was one of the problems. And the diode is, in case you have this piece and you can't read it, I had to use a magnifier, of course. It's we get the 1N5817 diode. And that's what was in there, and that's what I put in there. You can see there's one missing. And it works better. I clean all the corrosion off. It works better. So here it is on power. Now it takes 4 AAAs, as you know. 2 of them are right here. Right now I have it on AC. What the diode does is it prevents the power from here to affect these batteries so that you don't blow the batteries up. So it's kind of important. But it takes 6 volts worth of batteries, but it only runs in 5 volts AC adapter. If you run it at 6 volts, so right now it's at 5 volts. It's bouncing between 5 and 5.1 because it's like 5.05. It's running at 100 milliamps or 0.1 amps. If you put this to 6 volts, this thing is drawing about 1.5 amps, which is really excessive, and that train is just smoking around the track. Lights are really bright too. So the reason it draws less than 6 volts is because batteries don't have the amperage capacity. They can't put out as much amperage as direct power. So the machine it's hooked to will put out 2.5 amps continuously if it's called for. It's not calling for it. It's only calling for 100 milliamps. So it's only going to send 100 milliamps. The unit determines what it's going to draw based on the voltage and what's inside of it. But it does work better on AC power. Oh crap, I just smacked the pulley there. Gotta be careful. I unglued these wires, so if I turn it too much it gets caught on the pulley. These 2 wires right here that were glued right there. So anyhow, if you put the batteries in, so I'm going to turn the power off. I'm going to pull the AC adapter out. So what I just did is I just used a Limax connector with that to send power to it. I do have this style on AC adapters, except that they put out a much higher voltage. I don't have one that's 5 or 6. So this can run off of a cell phone charger or a USB to barrel connector. So here it is with the batteries. And you can see the train going around. Let me move my finger so I don't catch it. Now, let me show you what it looks like in low light. Lights are going off. You can see them, and then if I turn it over, you can see all the dots. They're all on. I did resolder all the connections too, just because they were corroded. I cleaned everything with rubbing alcohol and toothbrush, like I said. I made it as good as I could. Now, we'll plug in the AC adapter, which is right there. And I'm going to turn the machine on. And you can see the lights are brighter. Train's moving a little bit quicker. And I'll turn it so you can see the bottom. See those lights are a little bit brighter. I would not recommend having battery. Oh, sorry, lights are coming back. I would not recommend having batteries in here while running it on the AC adapter. The reason I say that is this diode only protects 2 of the 4. So even when the power's off, the AC adapter, the machine, is showing almost 0.5 amp because it's trying to charge these 2 over here. I don't understand why they did it. It's just the way this is set up. A lot of these tell you not to run batteries and AC adapter at the same time. Limax, as an example, says that on their battery boxes and their paperwork. Most people don't read it though. This one has nothing written on the bottom, so it probably would have been written in the paperwork or the box. If you can, this would be much nicer to run on AC adapter than the batteries, but it's designed for both. So I am getting 3.2 volts here and 3.2 volts here, which is 2 brand new AAA batteries. And I mean brand new. I swapped out the 4 I had in here that were 3 Amazons of one Duracell to 4 brand new Amazons that just got delivered. And I am getting 3.2, 3.2, so 6.4. If I put 6 volts in here, the train is going at like a bullet rail speed, and the lights are really bright. And the amperage draw is 1 1/3 amps, which is super excessively high for this unit. This unit shouldn't draw more than 100 to maybe 150 milliamps, and it's drawing 10 times that. So it is a 5-volt AC, and I'm assuming the other one's the same, and 6-volt battery. There's several pieces out there, not just miniature villages, that you'll put in 5, 6, 7, 8 batteries, and then you look at the power supply and it's weaker, and then the batteries would be all together. And that's because of what a battery can sustain for amperage draw versus what a power supply AC adapter can sustain for amperage draw. Batteries can't hold up. As soon as you start using them, they start to degrade. They get weaker, weaker, weaker until they don't work anymore. Your AC power supply, most of them will last you decades. So at the moment, I've cleaned all the contacts. Resistor is good. Got a new diode, since the other diode had, when I unsoldered it, when I took the glue off, it had started leaking or melting from the backside. And I'm like, not so good. Let's replace it. And then as soon as I did, it got brighter. And all the lights are now the same brightness, not some are dimmer like it was before. So that's a positive. I also did test one of my LEDs on this circuit. It's just as bright as the rest, and it goes to the brighter with this. So it's not the LEDs having a problem, like there's one that's dying and it's overdrawing and it's making them dim. It's literally the corrosion on the terminals. This terminal is really bad. Not only did I have to scrub it, I had to scrape it with a razor knife, get down through the outer coating, because the corrosion was so bad it has actually destroyed the surface of the metal. And it took a lot of solder because it wouldn't stick, and flux because it wouldn't stick. Battery acid, well, it's acid, it corrodes. So you're not supposed to keep batteries in your units. People do, I do, we all do. You got to clean them. Unfortunately, this one of the 4 that were corroded took the brunt of it. And this is the one that started causing all the problems, and that's corrosion is probably what also helped eat through the diode. So at the moment, I'm going to leave this one as it is and compare it to the one that's over here. So I'm just going to put the bottom on so it pops back in. I'm going to pop out the batteries. And I'm going to set it over here with the battery cover. And I'm going to move all the screws over to there. And now we're going to see this one. So this one, let's just give it 5 volts and see what happens. Lights are going off. Move my finger so the train doesn't hit it. So this one at 5 volts is drawing 300 milliamps or 0.3 amps. And that would be because there's more lights. Here's 1, 2. There's a lot more lights in this one than the one, well, you can't see my hand, but the one that's over there. But these still appear to be dimmer. And they may not be dimmer, because what I have noticed is some of these houses have less material on them than the rest, meaning the paint job and the flocking. So it's drawing 0.3 amps on, lights coming back, on battery power, or not battery power, AC power. AC power supply, DC is what's going into it. So I'm going to turn it off. If I can find the switch. There we go. And let's pop in some batteries. Let's find a place to... This one's got some corrosion. Let's clean that. I haven't cleaned this one yet. You can see the corrosion. But the part where the batteries go is not that bad. So let's see how it works. I will open it up. go. Train's working. Lights are going back off. So, still bright. Looks as bright as it did with the AC power, actually. These are still slightly dimmer. I'm going to open it up, see if it's a wiring issue or if it's just the paint job and flocking. Train's a little bit slower, but then again, batteries aren't as strong. But there you go. Power, lights are coming back. There we go. It's the fun thing about turning the power on and off. The camera flashing because of the bright light. And that's only 2 of the 4. I also noticed some of these screws down here are rusty. That's never a good sign. Like this one's got rust on it. This one's got rust on it. You can get rust from corrosion eating through the metal, or you can get it from moisture, of course. This one's got rust on it. This one doesn't. This one doesn't. And this one doesn't. So it's just the 3. But what caused the rust? Just trying to get it to separate. There we go. It's a nice tight fit. Looks like this one has to go this way. So there's our inside. And let's see if these glues look a lot better than the other one. They don't look all burnt and distorted, but the resistor's gotten warm. This diode looks a lot better. It's not all covered in corrosion. Where did I put it? Oh, it's right there. Then put it away. See if it's the same diode. So this is what I use to look at it. You can get yep, same one. 1817. You can get an expensive little microscope that connects to your phone or TV. It's digital. You know, for cheap ones are like 20-30 bucks, and the expensive ones are much more. But $10 at Walmart does the same thing. And you know, somebody in your household's sick, you can look in their nose. So works for me. So it's the same diode, and this diode's clean. There's no corrosion on it, not like the other one did. I'm just going to do a close-up to verify there's no corrosion on the solder joints. Yeah, these solder joints on the diode look much better than the other one did too. Take a closer look at the resistor. Resistor looks good. I'm going to go ahead and pop off the glue and see what the solder looks like on the battery terminals, since of course there is corrosion. That one's shiny. That one's not glued, so it's, you can see it, it's shiny. That one's good. So this one looks a lot better. Now I'm looking at the LEDs. I don't see any corrosion on any of the solder joints. They all look good. Oh yeah, this is the fun part of doing all this stuff, is you just kind of just stare at things and look for anything obvious. Get a little light up in here. That one looks good. That's the last one in the string. The wires are just twisted at the termination. Yeah, they're just twisted. That one looks good. And I'm glad I have this. I can see inside the hole. And that one's good. So there's no corrosion on these LEDs. There's no corrosion on those. The corrosion was all in the box. So let's turn it back on. This house, yeah, the 1, 2, 3, 4 over here. See, from the bottom, I don't want to set it to where the train gets bound up. The lights are all, you can't see. Let me turn off the lights. So, it may not focus very well, but if you, oops, I'm about to drop the base, losing my grip, there we go. So it's not going to focus very well because of the dots of lights. It can't focus on all of them at the same time. But if you notice, they're all the same intensity. I know the camera's trying to focus, so it's getting bright and dim. But you notice the ones here are just as bright as the ones over there. This one, and the one in the middle there, those are the ones that are dim on this side. But they're not dim. It's the paint on the house. Now, on the other piece, they are dimmer. And that's why I was adjusting the solder joints. Or they were dimmer. Let me rephrase that. They're all the same brightness now. Lights are coming back, so the camera's going to do its flash thing. I'm going to turn on all the lights here. One more. There we go. So this one just needs a good scrubbing. The battery box, just like the other one over here did. But this one is brighter, but it's also drawing more power because there's more LEDs. So I don't think there's anything wrong with this one. I think I have to go back to that one and see why those other LEDs are still, all of them are dim. I guess either there's something in the wire that's not right. One of the LEDs might be dying. They're all testing good, but that doesn't mean anything. So if you take a gander and look at like this house, which is dimmer, you know what? I'm just going to zoom in. Let me put the base on so it doesn't fall off and break those little thin wires. There we go. And turn the power off and use my pointer. So I'm going to zoom in and show you what I'm talking about. See how painted this house is? It's all red with the white roof. Then you look at like this house, it's tan. Or if you look at the, you know what? I'm going to turn it on so I can actually see which ones have lights because they don't all have lights. So this one doesn't light up. This one lights up. Right there. I'm going to turn off this and this. You should still get some focus. It's blurry. Man. Technology. I think it's because it's just too much depth. But, so this house is tan. It's a brighter house. this house and this house have bigger windows than this house. These have cut out windows. This one doesn't. Yeah, I don't think moving it around too much is going to help. Back out a little bit. It's a better focus now. Turn this off. So, the really bright one right over here. Right here. I'll put my screwdriver on it. Lights coming back. So this house is the tan house. This house is a red house. This house has big open windows. This house has no open windows. Same with this house here. No open windows. I think it's one of the reasons why it looks brighter is because the paint and the style of house is slightly different. As far as brightness of the LEDs, they're all the same brightness. It's just how it's shining through the plastic on this piece. On that piece, a couple of the LEDs were dimmer. Once I did the solder joints and cleaned all the corrosion, they got brighter, but they're not as bright as this one. And this one draws more power than that one, which is strange. Well, strange that that one's not as bright. And I'm going to pop out some batteries here. You have to pop out 2 batteries to shut it off. So here's one battery. Now the train's moving really slow. And pop out the other battery. And that's because, again, it's 2 segments of 3 volts. And what I'm going to do is plug in the AC power again. And we're going to see that the other ones are still dimmer. And 5 volts. We're going 0.29 amps, which is 290 milliamps, and power off. So now they're really bright, but if you notice, these are still dimmer. Really bright, dimmer. It's going to be the paint. I'm bringing one of the lights back so we can take the bottom off. I need to be able to see what I'm doing. That way I don't break the train or any of these hair little wires. I'm going to have to say, one thing about Hawthorne Villages, they do make sure that their stuff fits nice and tight together. So I used to have some of their pieces. So I'm going to turn the light back off. So now we can do the bottom and the top. So there's the top with the ones that appear dimmer. And we'll go back to the bottom. And they're all the same brightness. Hey, zoomed in, the lights look a lot better. Look at that. See? Same brightness. So the 2 at the bottom of the screen by the motor, and the 1 in the middle where the wires are crossing it are 3 of the dim houses. And then if you look and compare it to the other ones, just take one of them. Because if you do them as a group, of course they're brighter. They're really close together. If you just compare one on one, they're the same intensity. I have a lux meter that would tell me the same thing. Now these are mine. I'd run them on AC power just because it's a little bit brighter and the train moves faster. So this one just needs a good cleaning. All the gears work. Lights are coming back. Here we go. Oh, I guess while zoomed in, you can look at the detail. I'll center it on the screen there. Get a good, nice look at the detail on this thing. You can see the gear once the train clears it. You see the gear right there that drives the track that goes all the way around. You can see the track moving. There's the gear. You can see the track moving. So, train's just stuck on one section of the track. If this ever breaks, I don't know if you could ever replace the track. The gears, you can replace. Motor, you can replace. Belt, you can replace. LEDs, you can replace. Track, probably not able to replace. But there's a detail of this one. And it's very detailed for how small it is. Very itty bitty. It's a nice piece. It's nice and quiet. You can hear it, of course, but it's relatively quiet compared to most other animated pieces. So I'm going to push this one out of the way. I'm going to unplug it. Plug this one in. And we're going to this one's a little louder. You see this, the belt moving. I don't know where the gear is. I think the gear is underneath this. But this one is more intricate. Oh, I didn't realize the bottom was off. Here we go. So these are all little people, and I'll turn the lights off so you can see that brightness again. Yeah, it is so much dimmer. I mean, it is lit. But yeah, it's a lot dimmer. So I'm going to continue working on this and trying to figure out what's causing it. And I'm going to clean the other one. Lights are coming back so you can actually see what I'm talking about again. And I'm going to zoom out. Yeah, probably zoom in. There we go. So I'm going to clean the battery terminals on this one. And then I'm going to take this one apart and try and figure out what is causing the draw. It's a brand new diode. It has more power now. The train's louder and moving faster than it used to because the diode's not bad. So either there's another contact that's corroded, maybe the motor is overamping. It's still only drawing 100 milliamps. Now it's drawing 300. So I don't know what's causing it yet. I would like to make this one as bright as that one. That is my goal. If I have to, I'll replace all the LEDs. I do have LEDs that are almost the same color hue. They're slightly dimmer, or should be darker, or slightly brighter, meaning that it's either a deeper orange or a brighter orange or yellow, depending on how you look at it, than the originals. And that's because LEDs are like paint. When you make batches of paint, they're all the same color. You go back and remake the batch, it's going to be a shade or two off. Your eye may not pick it up, but that's how it kind of sort of works. But it works better, but it's not working at its best. So that's where we're going to continue. So I use, as I said before, alcohol, not the drinking kind, toothbrush, not the one you want to use your teeth anymore, and I do also scrape with the edge of an X-Acto knife or a small blade screwdriver to scrape some of the chunks out, the battery acid. So I think this is the second or third one in the last few weeks that have gone up that have had battery issues. The Snowman, the Elmo had the same problem, but I couldn't film the Elmo because it's copyrighted music and there's no way to turn off the sound. But I fixed an Elmo, that same thing, the batteries exploded, and I had to open it up and resolder the wire and fix all the corrosion. So battery acid's bad. Try and take them out if you remember. So anyway, I'm going to work on this one some more, clean that one, and then I'm going to see if I can find another power cord, have them running together, and compare them, and go from there. So it's not a very exciting video. It's not a very interesting video, but it's just informative as much as I can and show you the process without making it 4 hours long. So I shall return. Okay, we're back with the two Hawthorne pieces here, and they're not screwed together, but this one's now brighter. This one's still brighter, which is weird. I think, again, it's the paint, but this one's a lot brighter, and it was the resistor. It's over here somewhere. When I turn the lights on, I'll find it. The diode was bad, the solder joints were bad, and the resistor, which is weird, showed the correct resistance, and then as I was running it, the resistance just kept rising. So I'm like, that's strange. It's not supposed to change. At most, it might go down a hair. But I popped in a new resistor. The resistor I put in was bad. It was open from the packaging, which is strange. Again, kind of odd. Then I put in another resistor, and now I have bright lights. It's just, that's why I was having problems. It's just everything just didn't want to work like it's supposed to. So here's the other one. You can see the train's moving. Lights are, you can see how all those lights are really bright and those aren't. I already talked about it, but it's the paint. And then bring this one up. But you gotta be careful because there's a wire hanging out the side. I don't want to crush it. I have to glue the wires back down. See the train going around, and look at how much brighter that is. So let's try and get this to pop off. We turn the lights back on in just a second. There we go. Wanted to get that off. And lights coming back now. So there we go. Now it's back to normal. So, there's the new resistor. I had to go through my case of resistors to find same wattage resistor. I don't know where the other resistor went. Oh, it's right here. So this is a 1/2 watt. I didn't have a 1/2 watt in the right wattage. So this is a, well, it's a 2 watt. So I also didn't have any left in my 1 watts. So this resistor is never going to overheat because it is 4 times stronger than this one. So here's the one I put in that's actually bad that I dropped. You can see the size difference. So this is a brand new kit. All the resistors are in there. And that one is open. So there's no resistance. And I'm sitting there fighting with it going, there's no lights. There's no motor. What's going on? I took my power supply directly to it to make sure I didn't burn anything out. And the lights come on and the motor comes on and I take the power supply back off. And when I talk about directly to it, I mean touching the wires, not the power port. But when I plug in the power port, same problem. I have motor, no lights. So I checked the resistance. You need to use your ohms on your meter right there. And it's open. Well, that's an open resistor. It's no good. So I got another one. And look, we got lights in motion. So they both are on battery power currently. They are both pulling the same amount of power when I do put them into AC. This one's actually a little bit more, and that's because it has more lights. When I say a little bit more, I'm talking 1/100 of an amp or less. It's negligible. And I did fix some of the grease on here. There was grease on the motor. Before the motor got covered like Leomax motors do, I wiped it off so it doesn't short out. So we now have 2 bright units, and I'm going to try and find a power supply to plug these into for the owner, because he asked. So this is 8 batteries, and these draw on the power supply at the 5 to 6 volts they can run at, a 1/2 amp each almost, so just a hair off. On the batteries it's a little less. Also on a power supply everything's a little brighter and the train moves a little faster, and that's because the batteries aren't degrading, or excuse me, the batteries are degrading and the power supply is not. So as far as this goes, either one, if you have these pieces or something similar from Hawthorne Village, they're not terribly hard to fix. You have to take out the screws and slowly slide it off, because these indentations for the standoffs are very tight, so you have to like pry a little bit. Be careful because you got these ferry wires right here and they're easily broken. You don't want to break them. So you have a yellow wire here now. It was black before. It's because when I went to move this wire, the end broke off, and I stripped it back and soldered it, and then the end broke off and the wire was just rotted. The wire, when you strip it back, should be copper colored like this, and it was black. which is usually corrosion getting inside the insulation and causing the copper to corrode. So I just found a piece of wire I had and redid the jump. So this piece took a resistor, a diode, and a piece of wire, and I touched up all the solder joints because they were all corroding. This piece, all I had to do was touch up the solder joints. The diode, the resistor, and the wires are fine. So this one just could have been made with different material at the time when it came out, different batch of wires, etc. Or this one was stored differently than this one, so this one experienced moisture, because moisture does the corrosion, humidity. So this one has a bigger resistor, just so you know, than this one. So this one has a 1 watt resistor, and this one had a 1/2 watt resistor. The reason is, this one has twice the lights as this one. So that means it's going to generate approximately twice the heat, approximately. So they have a fatter resistor. So it's slightly bigger than that, smaller than that. So it'd be in the middle. So these aren't too hard to fix. If you open it up and your diode's bad, like the original one, the diode was leaking. It had just gotten so corroded that the internals came out of it. That usually is caused by a short or an overamperage. But the diodes are easily found. Resistors, you can get them on Amazon, eBay. They come in kits, so you don't just buy one, you get a whole bunch. Sometimes you can get like a strip of the same resistance, but you're getting like 100. Get the kit. At least you have others for doing other projects. Because if you have one piece, you probably have multiple pieces, and you may need a resistor down the road. Wire, it's just 26 gauge wire. Any thin wire for LEDs you can use to make your new jumpers if they are rotted. This orange wire, I had to resolder and trim 3 or 4 times because every time I solder it, the wire would break. So I had to trim off about 1 inch of it to find good wire to connect to that diode. All the diode does is, so when you plug in this, if the batteries are inside, it doesn't backfeed the batteries. The problem is it only doesn't backfeed 2 of the 4. So I wouldn't have batteries in here if you're going to run it on AC power or an AC adapter, because it's still a DC unit. So the diode only protects these 2 batteries, not these 2 batteries. And these 4 batteries share the negative, and they share the positive with the jumpers. So even though they try to protect it, it is going to start pushing power through these 2 batteries, and they will pop, which might explain the corrosion that's inside. I mean, there's not a whole bunch, but there was some in the corrosion on the battery box. And the corrosion is only on one side with all the wiring on this one. On this one, it was on just 2 batteries. So I'm wondering if this one at one point was running on AC power with the battery still inside. Some units tell you not to run batteries and AC together because there's no reverse polarity protection. Some tell you it's fine because they do have protection. This has got 1/2 protection. You could technically put another diode over to the negative on right here where my finger is at, where the yellow is connected. But anytime you add a diode has a voltage drop. So if this all runs on a split 3 volts, 3 volts to the motor, 3 volts to the light, and the diode is on the light one, you put on the motor, the train's going to spin slower. So it's a trade-off. Most diodes have around a 1/2 to 3/4 volt drop, which means when it's running at 3 volts, it's now running at 2.5 or 2.25 volts, which these lights will barely, well, they'll turn on at 2.25, but they won't be as bright. And if that's your problem, you don't want to make it any worse. So as far as the motor goes, it is an RF 300 series motor. They're not stamped because this one fell out, which was weird. I had it sitting up like this, and I moved it, and it just came out of its hole. It's supposed to stay, but it says RF 300 on it, but it doesn't say CA or an RPM. I am assuming it's probably one of the slower ones, like the 8600 RPM, maybe the 10,000 RPM. I mean, if you want your train to move faster than they're both moving at the moment, you could put in a 12,000 or even the 20,000 RPM model. But remember, the higher the RPM, it's a little bit more amperage draw, so you're going to drain your batteries faster. Also, the speed is based on its optimum performance, which is at the voltage it can handle in the maximum range, which those motors are rated for 3 to 9 volts. So at 3 volts, these motors are going to spin slow anyway. At 9 volts, they're going to spin really fast. Now, granted, a 8,000 RPM motor and a 20,000 RPM motor at 3 volts, the 20,000 will be faster, but it may be negligible. So it's a trade-off, but it's the same motor that basically you use in all your Limax products if you use them. And some older Department 56 use these too. I would probably stick with the standard ones if you can find them. If not, try one that's a little slower. And if it's a little slower and it doesn't bother you, the train's moving slightly slower, then go for it. Because right now these RF series motors are getting harder to acquire. And when you do find them, they used to be like $1 or $2 a motor, and now they're $8 to $10 a motor. So get what you can. Most people won't know how fast a train goes. I've never seen these until they were sent to me in the emails to look at before it was sent to me in person. So I'm assuming this is the right speeds of both trains. It could be a little faster if maybe I used a stronger battery. I'm sure the Amazon basic batteries are great, but they may not be as strong as a Duracell or Energizer. So, and like I said, it does speed up a hair. Not much, just a little bit, if I use AC power. DC power, but from an AC adapter. So, but that's it. Very simple. Resistor, well, somewhat simple. Resistor, diode, new wire, and redo all the solder. The reason I haven't screwed it back together is I need to hot glue these like they had them so they don't touch the pins on the bottom of the LEDs. That's why they were hot glued as an insulator. And I got to re-glue these lights down. These light wire and motor wire down so that when I close it, it doesn't get caught in the pulley. That's why the wires were hanging out and I didn't have it clamshelled together because I don't want to slice these two wires. So I got to re-adhere these two wires to prevent damage to the wires from the moving parts. This one, I don't have to do much of anything to. I've already taken care of it as far as the glue. So there's not anything I need to do to this one. This one was, for the most part, fully functional when it came in, but because they're the same age, same part of the set, might as well check them both at the same time. And they're super light. I mean, it's maybe 6 or 7 ounces. So for shipping, it doesn't add much to send a second one in to have it looked at. It's a very small box, as you can tell. They're very small pieces. So if you have this piece and you're having a problem with the lights or the motor, open it up, check your solder joints. It's very possible they may be corroded and that's your only issue. If that doesn't, you need a multimeter. Voltmeter is great. Multimeter, you can test the resistance in the diode. And if you're getting improper resistance or no resistance, or the diode's not working, meaning there's no forward voltage going across it, you know what to replace. You do need a magnifier to read the letters and numbers on the diode, which is the part number. And the resistor has color bands. All you got to do is type in the color bands in the Google, and it will tell you exactly what the resistance is. Now, it won't tell you the wattage, but again, 1/2 watt, 2 watt. So if you have this, you're going to have between a 1/2 watt and a 1 watt. Stick with a 1/2 watt or a 1 watt, or just to be safe, just get 1 watts, because that one has a 1 watt and this one had a 1/2 watt. More lights, less lights. You can use your voltmeter to test the voltage coming out of the batteries. Maybe you just got bad batteries or corroded contacts. And the corrosion can be on both sides. That's why I had to redo the solder joints on this one, and this one. You know, actually all 4. But mainly these is because they were corroded. And the corrosion gets into the nooks and crannies and the solder, and it starts to separate. And that's why this one came off when I pulled the glue off, is because the corrosion ate through the solder bond. So you got to check them. And you can use a voltmeter for that as well, saying, okay, I got 3 volts, I got 2 volts. Well, check the batteries. If they're still putting out 1.5 each, you're like, okay, then I must have a high resistive solder joint. So, not too horrible. If your LEDs are burned out, they're really easy to replace. They're pretty much all accessible. You desolder the wires and kind of wiggle, push them, or pull them, sorry, with needle nose pliers like this, something that might have a longer nose to make short needle nose, medium, so on. So you can grab them and then just kind of twist and pull. They're pressed in, and then solder a new one in. These are yellow LEDs. They look amber, but they're the yellow colored caps. You can get the amber clears, but they'll probably be brighter because they're newer. And that's why I went through the different LEDs earlier to see which one would be it if in fact I had to replace an LED in here. Or all the LEDs, which luckily they're all fine, just bad components, easily fixed. So there's no circuitry, there's nothing in here. If you do plug on the wrong power there, you're going to fry things, you're going to pop the LEDs, or you'll smoke the resistor, you'll probably blow the diode, but it's all fixable. You don't have to worry about a circuit board that has a proprietary sound chip or anything like that. It can all be repaired for just a few dollars, basically. Granted, you might have to spend $12 on a kit to get the resistor, and you might have to spend $10 on 1,000 LEDs, but when you go into the grand scheme of things, it's a couple dollars per unit to repair. Even if you have to replace some of the wire, you can get wire cheap, or you can get it from other components if you hoard stuff. So, wire. It's from this is from one of those old shake flashlights. This is the wire inside the magnet goes through. And this is the same wire. It's coated in like a varnish. You just peel it off, solder the end. The solder heat melts through the varnish, and bam, you have a connection. And then this is still covered in varnish, so it won't short out when you close it. So, very simplistic, standard size belt. All the motor again is a standard motor, standard pulley. All the gears except for the top gear are standard in most hobby kits, and the track is probably going to be the thing you never want to have break. So other than that, it's a pretty easy thing. Any home tinkerer should be able to fix this one with pretty much ease. The switch and the power port, again, they're standard. You can get them on Amazon or eBay and other little places. They usually come in packs of like 5, 10, 20, 50. So you're going to have a few, but this is the standard 2mm barrel. It's 2 or 2.5, and this is a standard off-on switch. Just a smaller version with the little wings that screw in. Their wings are right here. They don't screw in anything because it's in this plastic housing, and then they use the glue not only to protect the wires, but it also helps hold the switch down so it doesn't come out. Same thing with this. I peeled the glue off to check the connections here, and there's still a little glue on the edge which is holding it in, but when I re-hot glue everything, it'll be fine. So other than that, you all know how I glue things and solder things, so it's pretty much done. They're both running. They both work. This one's bright. This one's bright. It's all good. We have the exact same intensity on all the lights. It's just a paint job on top of the houses that has affected their ability to be seen. Like I said, these are much darker houses than those, but when you look at the base, all the LEDs are the same brightness. Same with this one, all LEDs are the same brightness. And it looks, they all look bright, and the tunnel looks brighter because there's no, it's a tunnel, there's no paint, it's an open hole. So other than that, that'll conclude this one for the Hawthorne Village Thomas Kinkade set. This one's the Christmas Crossing, and I forgot what this one's called. Winding Through the Mountains. So I don't know if there's any more to this set, but it is a pretty neat little thing. Perfect for a tabletop display, or in a little perspective snow village all the way in the back. So it looks itty bitty. But there you go. So till the next one, thanks for watching. Quick addendum. There's a warning label. Do not use the batteries with the power supply. I think the lights are too bright. There we go. Yeah, we use 4 AA batteries, 3 volt, 3500 or 350 milliamp. AC adapter not included. Do not operate this product with both power sources at the same time. This will cause damage to the product. Yeah, it's because the batteries explode. That's what I thought. It didn't make sense why they had the one diode and not two. The other diode might just be to prevent backfeeding from the motor to the light so they don't flicker. But there it is on power. You can see how it's moving. It's a hair faster. It's pulling 0.15 amps, or about 1/8 of an amp. So anyway, I didn't realize that because I took the battery covers off and moved them out of the way so they wouldn't get lost or damaged. And it does tell you specifically don't run both because it will cause the batteries to explode. Okay, thanks again. Till the next one.